All right, let's look at the homework 4.7, problem number 2. All right, so there's a requirement that the girth plus length of a package cannot exceed 132, right? And then, we want to find the largest possible package, right? So let's do that. Alright, so let's say I'm gonna call one side of it, one side here x, and then so it's going to be a square, so it's going to be x by x, right? And the length I'm going to use L, right? So the requirement is the girth would be 4 times x, because you have 4 sides, plus length cannot exceed the 132. So I'm going to actually set it equal to 132, right? So we have that. All right, then the volume is easy to find. The volume is simply, so volume is equal to x times L. So it's going to be x squared L, right? Then we want to maximize this. All right, so since I don't want to deal with x and L at the same time, so I'm going to use this first equation and solve for L. So subtract 4x from both sides. So L is equal to 132 minus 4x. Right? I think we can pull out the 4. If you pull out 4 from 132 would be 33. And then minus x. So we have that. Alright, so then since we have expression for L, so I'm going to plug this guy right in here. Right? So we are getting, let's see, I'm going to actually put 4 in front. Then you have x squared from here. Then you have a 33 minus x. Alright, so we want to maximize this volume. Alright, so let's do that. Right, so we're going to have to find the critical number. So we take the derivative of v with respect to x. Right, so since 4 is just a number, I'll just put it here. And then we can use the product rule to take the derivative of the remaining. Right, so derivative of the first guy is 2x times the second, 33 minus x, plus first guy is x squared. And then derivative of the second is going to be negative 1. Right? So since you can see that there's an x is in common, so I'm going to pull out the x. So we have 4x. And the leftover term would be, we have a 2 distributed to 33, so 66. And then 2 is distributed to negative x, so it's going to be negative 2x. But you have another x, so it's going to be negative 3x, right? And the 66 and the negative 3x has 3, so I'm going to pull out 3, combined with 4, so 3 times 4 would be 12x. And 3 is pulled out from 66, you get 22. 3 pulled out from negative 3x, so it's negative x. So if you set that equal to 0, we have a critical number. So critical numbers are x is equal to 0 from here, and also 22. Alright, so we have that. Alright, then let's see. So we can probably, we can actually find the restriction. So the on the x value, so x has to start from 0, I guess. And then the largest possible x we can have is, let's see. So let's say you have no length here. So 4x is equal to 132. So 132 divided by 4 is 33, right? So 33. So 33 is the biggest. Right? So it looks like we have critical number 0, and actually that's a left endpoint too. And then critical number 22, and the right endpoint is 33. Right? So let's look at the volume. at 0, which is the left endpoint. And then we're going to look at the volume at 22, which is the critical number. And then the volume at 33, that is the right endpoint. Right? So let's compute that. Right, volume x equals 0, that's easy. You can just plug it x equals 0, it's going to be 0. Right, 33, same thing. 33 minus 33 is there, so that's going to be 0. Right, so if you plug in 22, so you have 4 times 22 squared times 11. 33 minus 22, so 11. Right, so what's this? 22 times 22 is 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4. So you have a 484. And then we have to multiply by 11 and 4. So multiply by 44. Right? 4 times 4 is 16. And 4 times 8 is 32. So it's going to be 33. And then 4 times 4 is 16, so it's going to be 19, right? But we're going to have the same thing, so 6391. So this is going to be 69212. Right? So the largest volume would be 21,296. Right? Let's type it in. All right, so we're going to have 21,296. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.